Good morning, students. Today we are going to see with magnetic field due to a circular coil carrying the current. Okay, so it is magnetic field produced due to a circular coil. Already we have seen with the question magnetic field due to a long straight conductor, is it not? Here also it is more or less the same. First, consider a current loop of radius r. So this is a current loop, and this loop has a radius which is written as capital R. Let I be the current flowing through the wire. So this current is written as I. Magnetic field at a point P on the axis of circular coil at a distance Z from the center. So we are going to find magnetic field for this point P, and this point P is at a distance Z from the center. So this center we are writing it as O. Okay, so this is the first one which we are considering for this magnetic field. Then next we are going to take with the diagram. So this is a diagram for this. As I've told you, this is a circular coil. Then we are considering a point P which is at a distance Z from the axis center point O, and this is a radius. This is a radius. This point we are marking it as small r. Okay, and here there are two magnetic fields dB. Now what we are going to write is this PC is equal to, this is the value of PC. So PC is equal to PD is equal to what? R. And that R can be written as, considering this to be a right angle triangle. Okay, so this is R, and here we have 90 degree, is it not? And here we have the value to be R, capital R, and here we have Z. Okay, applying Pythagoras theorem, the longest side square is equal to sum of other two sides. So it is R square plus Z square. Now if you need the value of R alone, R can be written as, take this square root to this side, so it becomes as root of. So root of R square plus Z square. So this value you have written here. So R is equal to square root of R square plus Z square. Then we are also considering the angle. So what are all the angles we are considering is angle CPO. Okay, so here we have the angle CPO. So this angle is marked to be theta, and same way DPO. Okay, so this angle also we are writing it as theta. Okay, so we have taken the value of theta and we have got the value of R also. Okay, now we are going to take with magnetic field, equation of magnetic field. Before that, this dB, this is the value of dB, is it not? This dB is going to be split into two components. So what are the two components is dB sin theta and dB cos theta. Okay, so when you see here dB sin theta, they are in the opposite direction, so they get cancelled. So we'll be considering only with dB cos theta. Okay, so taking with the value of dB cos theta alone, if we write with the equation, we know from Biot-Savart law, dB is equal to what? Mu naught by 4 pi ideal cross r cap divided by r square. Okay, now the next is we have to find the value of b from this. So integration of dB, we just now saw that this dB is split into two components, cos and sin. Sin we are cancelling, so we are just considering only with a cos theta. Since we have a vector here, we are writing with a unit vector which is k cap. Okay, now write with this value of dB here. Okay, so when you write with this value, we get mu naught ideal cross r divided by r square, is it not? So that can be written as dB we are writing here. So integration of dB value, I'm going to write it here. So we'll get as mu naught divided by 4 pi into I into dl cross r cap divided by r square. Yes. Now in this mu naught I by 4 pi is constant. So I am taking it out. So we are getting as mu naught I by 4 pi. Yes. Then the remaining terms are integration of dl cos theta, and we are just neglecting with this unit vector since its value is equal to 1. So if you neglect with that, you will get just dl divided by r square. So this is db. The remaining here we have got with cos theta into k cap, is it not? So we are writing with that value here, cos theta into k cap. Okay. Now taking this same equation, we are going to write the value of dl as well as r square. So this value of dl and r square will be finding from the diagram itself. Okay. So that value is given by cos theta is equal to, so take with this triangle I am taking. From this triangle, this is a triangle. Here you have the value to be theta. Okay. Here is the value r, and this side we have z, and here we are having the value as capital R, is it not? So what is the formula for cos theta? Cos theta is equal to what? Adjacent by hypotenuse, is it not? What is the adjacent side here? R divided by hypotenuse is what? Small r. Instead of this small r, this can be written as root of r square plus z square, is it not? So same way you are also writing here as root of r square plus z square. So this is the value of cos theta. This value of cos theta we are going to take it in the next step. Okay. So cos theta is equal to r divided by root of r square plus z square. So that is what is given here. Okay. Since because r square is equal to r square plus z square. Okay. Now substitute this value of cos theta in this place. Okay. So in this place we are going to substitute the value of cos theta. So if you substitute, the remaining terms are what? Mu naught I by 4 pi integral of dl by r square into cos theta, is not? So mu naught I by 4 pi. So I am just writing it over here. Okay. That same equation if you are writing here, we will be getting it as b is equal to mu naught I by 4 pi into integral of dl divided by r square r into cos theta. So it is r divided by root of r square plus z square, is it not? Now this I am writing it as k cap. Okay. So this is the value of r alone. Okay. Now sorry, this is r square. Okay. Now substitute this value of r square here. Okay. So we will be getting the step as b is equal to mu naught I by 4 pi. Now we are taking the integral limits. So what are the limits for this integral is, we are going to take the integral limit to be from 0 to 2 pi into a. Okay. So or we can also write it as 2 pi. Now when you write this dl as it is divided by r square value is what? R square plus z square. So we are getting it as r square plus z square into this r term as it is divided by r square plus z square, the whole power. So this can be written as, this root can be written as power of 1 by 2, is it not? So we are writing as power of 1 by 2 into k cap as it is. Let us take this limits to be 0 to 2 pi r. Okay. Now this mu naught by 4 pi as it is, we are writing it. Now see, when you see the powers here, this is to the power of 1. Okay. Because r square plus z square whole power 1. This when you see, it is to the power of 1 by 2. So when you add this, it becomes as 1 plus 1 by 2. So when you take the LCM here, 2 it goes here, so 2 plus 1 divided by 2, that is equal to what? 3 by 2. Okay, so this is the value which you get when you combine this both. Okay, so we are getting it as mu naught by 4 pi as it is. Next I'm going to write this term outside. Okay, so r divided by r square plus z square whole power 3 by 2. Okay, whole power 3 by 2 as it is. Then next is we have the term just integration of dl. So if you integrate dl, you will get the value as just l. Okay, so l to the limit of what? 0 to 2 pi into r. Okay, and k we are writing it as it is, k cap. Yes, now apply the limits here. It is upper limit minus lower limit, so we'll be getting the value as mu naught by 4 pi as it is. Okay, so mu naught by 4 pi into this term also as it is. Only here we are going to apply the limits, so we'll be getting it as r square plus z square. So this, sorry, r divided by this as it is. Okay, now into 2 pi r minus 0. Okay, now when you see here this pi, sorry, 2r it is. Okay, 2r, so we'll be getting the value as this 2 and this 2 gets cancelled, so the remaining is 1r. Already we have the r here and the denominator term as it is, so we get as mu naught I by 2 pi r into r, that is r square divided by this r square plus z square whole power 3 by 2 as it is. Yes, clear with this? But these steps are all not given in your reader. Only if you derive with this, you will be able to understand this. Okay, just we are substituting the value of r square plus z square here. Then when you multiply this, that becomes as power to be 3 by 2. This is to the limit 2 pi 2r. Okay, when you apply the limits, you'll get with this equation. Yes, clear with this? Okay, thank you.